Can JavaScript debugging tools help find memory leaks? Imagine trying to find a tiny leak in a boat's hull while it's floating in the water. That's similar to tracking down memory leaks in a web application. Developers often face the challenge of figuring out why their app suddenly slows down or crashes. This is where JavaScript debugging tools come into play. They are like a detective's toolkit, helping you see what's happening inside your code. These tools are built into browsers like Google Chrome and Microsoft Edge, and they are essential for web developers. They give detailed views of how memory is used during your app's run. For example, they show which objects are taking up space and how long they stay in memory. This is important because in JavaScript, a memory leak occurs when objects that are no longer needed are still referenced somewhere in the code. This prevents the garbage collector from freeing that memory. Over time, this can cause your application to slow down or even crash. Modern debugging tools include features like heap snapshots, which capture the current state of memory. You can compare these snapshots to see what objects are still in memory after certain actions. Allocation timelines are another feature that tracks memory allocations over time. They help you spot objects that keep getting created but never get released. Detached element profiling is especially useful in single-page applications or frameworks like React. It shows DOM nodes that have been removed but are still kept in memory because of lingering references. Real-time memory monitoring allows you to watch how memory usage changes as users interact with your app. You can record these changes and identify patterns that suggest leaks. To use these tools effectively, you can record memory usage during typical interactions. Then analyze snapshots or timelines to find objects that shouldn't be there. Once you identify the problematic objects, trace back to the code that holds references to them. Fixing the issue might involve removing unnecessary references, clearing timers, unsubscribing from events, or properly unmounting components. For example, in React, failing to clean up effects or timers in the effect hooks can cause leaks. In Angular, not unsubscribing from subscriptions can lead to similar issues. These tools help you see these patterns clearly. The Chrome DevTools memory panel is a popular choice. You can record an allocation timeline while performing actions that seem to cause leaks. It highlights new allocations with blue bars, making it easier to zoom into specific moments. You can then inspect objects, see their constructors, and trace their references. This detailed view helps pinpoint the exact source of the leak. In summary, JavaScript debugging tools are powerful allies in finding and fixing memory leaks. They give you a clear picture of how memory is allocated and retained. Mastering these tools is key to keeping your web applications running smoothly and efficiently over time.